Hello, this is Killer Symmetry by Dr. Logic. It's a 9x9 Sudoku with quite a number of rules, so we're going to go through all of them. So, normal Sudoku rules apply, as you can see here. That means 1 in every column, row, and 3x3 box, 1 to 9. Normal Sudoku, normal killer cage rules, that is, digits in a cage cannot repeat. So in these cages, obviously can't repeat because in the same box, but in cages like this, they also cannot repeat. So you couldn't have these two be the same value. Yes, the digits must also sum to the number in the top left corner of the cage. So for example, these two, this cage has an 8, so these two must sum to 8. So this could be a 3, 5. Okay, next, a white dot. Digits separated by a white dot must be consecutive. And I would assume not all white dots are given, which means that something like this doesn't have to be a white dot. Doesn't have to have a white dot on it, but can still be consecutive. So these two must be consecutive. This pair, sorry, mean that they must contain 2 consecutive numbers. Sorry if I didn't articulate that well enough. A black dot means that digits separated must be in a 1 to 2 ratio, so one must be double the other. So something like this could be a 4, 8, a 3, 6, something like this. Yeah, not all dots are given. So that is for both white and black dots, not all dots are given. And finally, digits cannot repeat along this marked diagonal. So this blue diagonal cannot have the same digit in there. And those are the rules. So let us begin solving. The first, the title says Killer Symmetry, right? I don't really see much symmetry, although I guess these clues are symmetric. I don't know why it's called Killer Symmetry though. Anyway, the first thing I would look at would be this 24 cage. And because 24 is actually the maximum number you can have a 3 cage be. And the reason why is because if you take the maximum possible numbers in here, that would be 7, 8, and 9, they add up to just 24. So these must be the maximum possible numbers, 7, 8, and 9. I don't see any other cells, any other cages with similar properties. Although I do note this 22 is quite similar to 24. 22 does have a few options though. I think 2 options. It could either be 985 or 976. So we can't disambiguate that at all. And I think we're gonna look elsewhere. I will say these symmetrical sections do remind me of something. So for example, this the trick that I think we're supposed to use here might be using the full box. So the full box has the digits 1 to 9, and therefore all digits must sum to a total of 45 if you sum the digits from 1 to 9. Now this cell is 15 and this cell is 15. So these 3 remaining cells would be 45 minus the 2 15 cages, which would give you another 15. So these sum to 15 as well. Now the question is, are there only 3 distinct ways of making 15, or are there multiple sets of 3 ways to make 15, if you know what I mean? I think that's a question we'll come back to later, because this is actually, I think, a bit more interesting. This is 19 and this is 19. Therefore, this must be 45 minus 19 minus 19. That would be 45 minus 38, which is actually 7. So these cells sum to 7, which is very interesting because 7 in 3 cells do only have one option, and they are, I think, 1, 2, and 4. And let me just check that. This is 19 and this is 19, that sums to 38. 45 minus 38 is indeed 7, so yes, this must be 1, 2, and 4. Therefore, this must sum to 15 without using 1, 2, and 4. So let's think about what they could be. Well, I think they must include a 3, because if they did not include a 3, then minimally you would need a 5, 6, and 7. But that already sums up to 18, which is a lot higher than 15. So it must include a 3 somewhere. With a 3, you would then need a 12. And 12 can be made in a few ways. It can be made with, let's see if I can note them down. 12 can be made with 5, 7. It could be made with 4, 8, and it could be made with 3, 9. Those are the only possibilities for 12. But we know there's no 3 because there's already a 3 somewhere else. We also know there's no 4 because there's already a 4 somewhere else in this diagonal. So it can't be any of these and must therefore be a 5 and a 7, which means that these cells are in fact 3, 5, 7. We can finish off the diagonal with our remaining values, which will be 6, 8, 9. And that removes 8 and 9 from this cell because this is a triple. So that can't be an 8 or a 9 and must be a 7. So that's our first digit. Nice. Okay, 8 and 9 cannot be in here. That's interesting. Well, I think I can remove 9 from this cell because there is nothing here you can put that is in a 1 to 2 ratio of 9. Because twice of 9 is 18, which you can't put in one cell. And half of that will be 4.5 or 4.5, and you can't put that in one cell either. So that can't be a 9. But that doesn't really help. I guess this 19 might be useful. Although I'm not exactly sure. This 8, 9 means this can't be 8 or 9. So maximally this could be a 9, 6, 7, but that's really high as well. In fact, that's really a 22, right? Oh, I see. Maybe this 22 is where we're supposed to look next, because these cells mean that this can't be a 6, 7, 8, or 9. So minimally, they can be a 5. These cells can then maximally be an 8 or a 9. Sorry, I said minimally, I meant maximally here. So at maximum, these are the contents of these cells, which do in fact sum to 22, I think. 5 plus 9 is 14, plus 8 is 22, yes. So we do need the maximum values to make this a 22. So it is upper bounded on the upper value. Okay, that's useful. We have another 8, 9 pair here. I also realized you could put some possible digits here. For example, if this was a 6, this cannot be a 12, so it must be a 3. Similarly, if this was an 8, this can't be a 16, so it must be a 4. Okay, that's somewhat useful. Ah, I see. In this box, this 8, 9 pair sees these two cells, and this 8, 9 pair sees these two cells. So 8 and 9 can only reside in these two cells, which must be therefore the 8, 9 pair. We're left with 3, 6, 7, and 5. 3, 5, 6, 7. Okay, well, let's think about it. Both sum to 19. So if this was a 9, you need a 10, which is only made possible with a 3, 7. So 9 is always beside 3, 7, and then 8 would therefore always be beside 5, 6. That's useful. Now this cell does lie on a black dot, and therefore we can remove some values. For example, 5 doesn't work because this can't be a 10 or a 2.5. 7 also doesn't work because this can't be a 3.5 or a 14. So that can't be a 7. And now this is actually just a 3 or 6. If this was a 3, this must be double that because it can't be half. So that's a 6 if this was a 3. If this was a 6, then it can't be 12, so it's a 3. Meaning that this does form a 3, 6 pair. We do know that this is either 10 or 11. If this was 3, this must be the 10, so that's either a 7. If this was a 6, this must be part of 11, so this is a 5, meaning this is only 5 or 7. Okay, that's useful. What next? This doesn't tell us anything at all, because we don't know which pair this is exactly. Although I suppose this 10kh without 8 or 9 does seem a lot more useful, because we only have a few more options left. We only have 3, 7 and 4, 6. But does 3, 7 and 4, 6 remove any options at all? I'm not entirely sure. Well, okay, this is the obvious thing we're supposed to look at next. I didn't actually see this one because similarly with this cell, this can't be a 5 or 7, so it must just be a 3, which therefore must have a 6 next to it. Those can't be 3. If there was a 6, these cells must sum to 9 and cannot be 3, 6. The possibilities for 9 are... Well, there are 1, 8. Sorry, not 2, 8. 1, 8. There's also 2, 7. 3, 6 isn't usable, and there's also 4, 5. Ah, but these 5 and 7 remove the 4, 5 and 2, 7 possibilities. So we are only left with 1, 8, meaning the remaining cells must be 1 and 8. These remaining cells are therefore 9, 2, and 4, which do in fact add up to 15, so that's useful. Oh, well, that's correct. That is good. Was I saying anything about this 10? Yes, this 10 is either a 3, 7 or 4, 6, although we haven't disambiguated it yet. I'm not sure if it could be anything. For example, a 3, 7 here. Ah, therefore this can't be 3, 7. Yes, because if this was a 3, 7, this would then have to be a 4, 6. But that fails this cell, because 3, 7 and 4, 6 removes 3 and 4 from this cell, so eliminating all candidates. That doesn't work. So this can't be 3, 7, and it must be 5, 6. Which I will put properly. Which does help. That can't be 5, 6, and this can't be 4, 6 because it already exists as 6. So that's a 3, 7. That removes 3 from this cell, so that's a 4. That's an 8, therefore. This 6 means that's a 3. This 8 cell doesn't really do much. Okay. We have a lot of progress, which is definitely useful. This 4 means that's no longer a 4. And this cell is either a 1 or a 2 along this column. I can't disambiguate that either. What do you think we're supposed to look next? I want to say is this 8, because 8 does have only 3 options. It's either a 1, 7, 2, 6 or 3, 5. We have removed 3, 5 from this cell because it can't contain a 3. But it could be a 2, 6 or a 1, 7. I don't think it matters. So, not entirely sure. Well, this 3 definitely helps because that is disambiguated, which does not in fact disambiguate this, so I'm a little bit shocked at that. Have we deciphered what this 9 is? I think we tried, didn't we? No, we deciphered this 9, not this. This is not 9. Well, this is 9, but there are a lot of options for that. Maybe this crop key dot. Because we removed 8, so this can't have a 9 on it. Therefore we do have only a few options. If it had a 7, it must have a 6, and if it had a 6, it can't have a 5, so it must have a 7. So this is either a 6-7 pair, or if it's less than 4, it could be a 1, 2 or a 2, 3. So there are a lot more options than I thought there would be. That is quite unfortunate. Oh, it's this 10 cage, isn't it? Because we have removed 3, 7 as a possible pair. We have removed 9, so 1, 9 is impossible, and 8, so 2, 8 is impossible, meaning this is 4, 6, which is resolved by this 6 here. So that's a 4, that's a 6. This must be in a 1 to 2 ratio. Yes, and it can't be 8. So this can't be double of 4, so it must be half, so that's 2. That does disambiguate this, which is helpful. What? I didn't remove the right number. Oh! So 2 is removed from these 2 cells, meaning that's a 2. 1 is removed from that, so that's a 2. Does that help with this? I think it does. Well, not entirely. This does remove 2, 7 as an option, because it's a 9, right? It also removes 4, 5 as an option, but it could still be, this 6 means it can't be a 3, 6, so that is a 1, 8, which is unfortunately not yet resolved. Oh, this looks interesting because we also have a 1, 8 pair there. So in this box, 1 and 8 must reside in here. And if 1 and 8 exist, they sum to 9. The remaining cell, to sum to 14, must then be a 5. So it must be 1, 5, 8. This is 5 and 8 means that's a 1. This can't be a 5 because of the reasons we have spoken before. So that's an 8. That is a 5. This is resolved, that's a 9, that's an 8, and this must be half, because it can't be 16, so that's a 4. That is a lot more progress, which is good. This 9 disambiguates that, so that's a 6, that's a 9, therefore this is ambiguated. Sorry, that's ambiguated, this is disambiguated. In this row, that must be a 5. These cells we cannot conclude because of this 5, 7. Although I can say, in this column, this 5 cannot be in any of these cells. Therefore 5 must be there. That's a 5, that's a 7. Okay, what else do we have? Nines? These two nines look at this box. So now these can be nines. This 4-9 pair also looks at that, so that can't be a 9, means that's a 9. Okay, what else do we have? I don't think we're supposed to do regular Sudoku yet. Well, these two 4s look at this box and say that's a 4. What else do we have? I mean, we have a lot of other cages we have yet to look at. Let's look at these two cells in this column. Actually, that's a lot more simple. It has to be a 7 and 9, which also can be disambiguated, interestingly. But that must therefore be a 3-5. Yes, which is disambiguated by these 3 and 5. This 3 also helps. That must therefore be a 2, which is good. That doesn't break the puzzle yet. I've been doing these puzzles a lot, and a lot of the times they break, either because I make some random incorrect assumption, or I just happen to do my math wrongly. So I'm making sure my math is right. This must be a 3, 6, 7, which is useful. That's a 6. Oh, that's not a 6, and that's a 7. We don't get much more help though. Although I can say this, well, I don't know what this is. It could also be a 3, 6 pair. We do only have 2 options for that pair though, because 4 and 8 are removed from that. How about this row? Yes, because it can't be a 1, this must therefore be a 2, 3 or a 6, 7. I guess that isn't really helpful either. 2, 3 or 6, 7. Yeah, not exactly helpful. Okay, I think we look somewhere else. Is there anything that I happen to have missed? Any glaring... No, I don't think so. So I think we do look at the new cages. Either that or... These 7s and 3s. Yep, okay. This 3 must be in one of these cells, and this 7 see all of these, so 7 must be one of these cells, so these are 3 and 7, which makes sense because they sum to 10. So we actually didn't need this 10 cage. I guess it probably would have helped make the puzzle a lot more smoother to solve. This, can we disambiguate? No, we still have only removed 3, 5. We haven't actually removed any other options yet. Oh no, wait. Oh yes. We have removed 3, 5. We also have removed 2, 6 because 6 sees into this entire cage. So this is 1, 7, which disambiguates this because this can no longer be a 7. That's a 3. That's a 7. The remaining cells are 2, 4, 6. Yes, 2, 4, 6. This 6 means that's no longer a 6. That forms a 2, 4, 6 triple. The remaining cells are a 1, 7, 8, 9 quadruple, which I can't figure out yet, so no. That's almost all the clues done. We just have the crop key clues left to figure out. Oh, can I do this? I should have done that. I'm sorry, this 19 cage already has 11 in it, so can only have 8 remaining, so that does disambiguate a lot more stuff. This is a 7, 9, 7, 1. Yeah, that I should have done that a long time ago. Okay. What else do we have? Maybe this column. That's 2, 5, 8. This can't be an 8 or a 5, so it's just a 2. These are 5, 8. Okay, maybe this now. Look at this 5. It would have to be... Well, it could be a 4 or a 6, actually. We don't actually know. If this was an 8, this can't be a 7, but it could also be a 9, so we haven't done anything much. This from this box we know is a 1, 3. That looks at this, so that's a 7. Somewhat helpful. What are these? We knew this was either a 2, 3 or a 6, 7, right? But it cannot be a 2, 3 anymore, so it is just a 6, 7. So that's a 3. That's a 6. These are 1, 3? 1, 3. And these are 2 and 5. We can remove 5 from this because 5 can't be next to a dot, a black dot. And 2 is only double of 1. That does help a lot because that disambiguates this, which then follows up by disambiguating that. Okay, that's a lot of progress. What do we not have in this cell? I guess we look at... I mean, there's a lot of stuff to look at. Anything... this 2, yes. That's a 4. That's a 2. This is therefore a 4, because that can't be a 2 anymore. 2, 6 pair. Also not resolved. Let's look at the columns then. This is 1, 9, 1, 4, 9. I don't think we'll get much of these because, yeah, I see a lot of repeats in the top 3 rows. 5, 6, 8. Oh, we can remove 5 and 6 from that, so that is an 8. Oh, that helps. Because that disambiguates this. That's a 1. That disambiguates that. So this is another 4, 9. Which also isn't fixed yet. That's weird. Okay. I guess it didn't really help, so we do have to look at other stuff. Well, this 3 fixes that. That's a 1, 3. Are we really stuck here? No, this has to help. We're missing 1, 2, and 6. Yes, and the only set that is 1 double the other in here is 1 and 2. So that can't be that. So that's a 6. That's a 2. This must contain 4. Wait, no. Yes, 4, 9, and 6. 4, 6, 9. Which we can fix. Yes, because... Oh, what? No. Oh, this 8 fixes that. That's a 5. That's an 8. So this can't be a 9. We don't know about this one. So this 8... Oh, this 5 should... Yes, it does disambiguate. That's a 5. That's a 6. Sorry, that's a 6. That's a 5. That's a 4. That's a 9. That's a 6. And then we are basically home free. This can't be a 4, 9. That's a 1. That's a 2. That's a 1. This is a 4. And that is a 9. Congrats. I have solved the puzzle in, well, barely 20 minutes. I guess in just over 20 minutes. Yes. I hope you enjoyed that puzzle. I'll see you. Bye bye.